I thought maybe we'd just take a nice little intro to motion this morning using the packet that we haven't really gotten to get into, and then making our way back to a really good sample problem for your homework that's not as abstract as the one that we did yesterday, that paragraph one that we ended with, while trying to address questions you guys might have come up with last night in homework. For those of you guys who were absent, we did just take that integration quiz. It was 3 integral problems like we did yesterday in class. Hopefully everyone remembered to see that their entire answer was there, but you will be responsible for coming to me and getting that made up when possible. Here we go. So motion packet's open on the first page. What have you guys been able to fill in? Let's go in order. Initially means when? T, or time is 0. Good. At the origin. Now this might have been a little tricky, but at the origin means when? Position. It's similar to hit the ground. You can put hit the ground in parentheses if you want, because in an up-down model, hitting the ground would be being at the 0th position. Unless you made the 0th position the top of the building, then maybe the ground is like negative 80 feet or something. But otherwise, hit the ground could be another way of doing it. But if you're on like an x-axis or a y-axis, the origin would be when position, s of t is equal to 0. At rest means when velocity, or technically you could have said speed, but velocity is the more typical one. Speed and absolute value is harder. Hey, speaking of speed and absolute value, did that fill in anything? No, maybe not? Not in this page. Okay, number 4. If the velocity of the particle is positive, then the particle is moving to the right. Maybe look down here to see left and then just do the opposite? Yeah. That'd be smart. So then how about this one? Well, if this one was positive, what's the velocity in this one? Negative. However, can you guys add to this in parentheses, right or up, right? Because it could be an up-down one. Dimensional motion or linear motion, and then down here left or down. Left or down. Remember, we're just doing a linear motion, aka in a straight line, either strictly horizontal or strictly vertical. Number 6, to find average velocity over a time interval, divide the change in position by the change in time. And that was what you guys told me on our review of our forever cards when we did S of B over S of A all over B minus A, right? Change in position over change in time. That's underline the word average. Instantaneous is the velocity at a single moment in time. Can you guys fill in anything right after that to give you a hint as to how to solve it? Derive what? Position. So we could do S prime of t, right? The rate of position. The rate, we can take a derivative. Or ds dt, that works too. Number 8, if the acceleration is positive, then, wait a minute, we have a positive quantity who's the rate of somebody, and that somebody will be increasing. Who is acceleration the rate of? Velocity. Nicely done. Velocity is increasing. Velocity. Remember that increasing word of a quantity means its rate is positive. The rate of velocity is acceleration. dv dt is dA, or is a of t. If the acceleration of the particle is negative, then obviously velocity must be decreasing by the increasing and decreasing test. Then last but not least, in order for a particle to change direction, the velocity. Yeah, it can't be speed because speed doesn't have a sign. It's always positive. Position signs just indicate displacement, like, oh, I'm to the left or to the right. But question, couldn't I be to the left of like the podium and still moving right? Yes. Couldn't I be to the left? So my position could be negative in the sense of negative displacement, but my velocity would be showing what direction I'm moving. Because even though I'm to the left, even though my position is negative, I could be going left or I could be going right. I need to look at the sign of my velocity. So question in homework. I only know because Adam asked it yesterday. Question in homework, or you were looking at it yesterday. If it asks where something is moving to the right or moving to the left, hence wherever velocity is positive or negative, what do we have in our arsenal, in our toolbox, in our previous math experience this year that would help us figure out the signs of velocity. The signs of the first derivative. How do we analyze signs? What do we set up to figure out the signs?
Sign chart.
A sign chart, yeah. Sign chart. Sign chart. So maybe you guys have a little bit of space. Oh, we're supposed to use that to do something. Let's come up here. We skipped this one. Did anybody realize that this was asking a question?
I realized it.
The three closely related concepts. In section 2.2, we would have said position first, and then velocity, and then acceleration. But have you guys noticed what order I'm going in now that we know integration? Yeah, going this way is, hey, the rate of, and then the rate of, velocity is the rate of change of position, and acceleration is the rate of change of velocity. We're taking derivatives, but now we can go backwards from acceleration to velocity to position. Just be careful of your plus C's, which are going to be like your initial conditions, or you're going to have to use initial conditions to solve for. But we can be using integration to go backwards. However, can we put one more little note up here, kind of off to the side, because I think you guys should have space, right? One little note up here, off to the side, in conjunction with this whole velocity increasing when acceleration is positive, or even better, position is increasing when velocity is positive. If we were trying to, or if we needed to, analyze the signs, couldn't we do a sign chart of velocity to position? Now, guys, what would we still be using to separate my intervals? What's always separating intervals in a sign chart? Yeah. Crits, right? We use crits. So then we would use something like, let's see, we call that A and B, where A and B are where velocity equals, I can do it this way. Velocity is never going to equal dNE, so we don't actually have to worry about that kind of funny thing that happens, but we should have velocity at these crits being 0, right? So they're resting points. Another snazzy way of saying it is stationary points or resting points. But they're just crits, to be honest. And then if I figure out things like positive or negative or positive, you guys realize that could be like moving right and moving left and moving right. Or moving up, moving down, moving up. It depends on the motion as to exactly what's going on. But the signs of velocity, if I were you, I'd put something about the signs of velocity will tell me whether position is moving to the right or moving to the left. That's kind of helpful as far as thinking about the signs of velocity, etc. So moving left, moving right kind of helps us, or moving up, moving down. And what would happen if we were doing a sign chart of acceleration instead, a second derivative sign chart? We wouldn't be using resting points, aka when velocity was 0, we'd be using, sorry, ooh, A of A, that's awkward. Let's do like C and D. I can get rid of histogram. Is that bad? A of C and A of D. Once again, acceleration will never not exist. It'll either be 0 or it'll be a number, positive or negative. But those would be crits of acceleration, another way of saying that, or I should say crits of velocity. Zeros of acceleration when there is no acceleration. And we would be testing what's going on in velocity, but we could also maybe test some of what's going on in position. That's concavity, though. If we figure out acceleration to be, I don't know, whatever it is, that would mean that velocity is, decreasing or increasing. Just quick little reminders as far as these words and how we should be figuring them out, or we could be analyzing them with sign charts, etc. I don't know, just it might be helpful to make motion sign charts to know what's going on. Did you guys get to look at all at worksheet number 2? Give me an honest yes or no.
No.
Okay. So some of you maybe just peeked at it for a second. Let's go ahead and pause on that for a bit then, just because we do have a book homework that's due tomorrow. Leave your motion packet out because we're coming right back to it in just a second. But if I were you, open up notes, because this is what's going to be helpful for finishing up that book work. Some of you got a little overwhelmed and you kept on being like, there's more, and there's more. There are more. There's another one, there's another one. Not all of them have like an A, B, C, but some of them are kind of the awkward paragraph of, aw, stink, what am I supposed to do? That's why we did the awkward paragraph yesterday. It's not as clear cut as this one that says, okay, focus on, okay, focus on, okay, focus on. So we're going to do this problem first, and then we might go back and look at the paragraph for one more second. I didn't show how to finish this problem. But it's because it's from Algebra 1, a system of two equations. Well, maybe Algebra 2 level of equations, because one's a quadratic and one's a linear. But it's a system of two equations. Once you plug in all your clues, and then all you gotta do is solve for one in terms of the other. Plug it in, and use your math skills as far as solving for V sub naught. Now, if you guys don't like these little zeros getting in the way, I don't mind you making it another letter or just calling it V. If that makes it easier in your head, this little sub-zero is just a name. It's just which velocity. Oh, the 0th one, or the initial one, or the beginning one. It's just a name. I could have V1, V2, V3, like after 1 second, 2 seconds, 3 seconds. If you don't like him, if he gets in the way, you can go ahead and just call him V. Just remember, he's only the initial. But let's do this one. It's a little more straightforward. I'm going to zoom in on him, and then we'll go back to what do you do when you have a nasty paragraph and they're trying to have you solve for something that's not super clear. What do you do when your smartboard doesn't work? Come over to the mouse and you hope that it works. Okay, here we go. Get down your important information, yeah? Oh, hey, and the directions, they were nice. They gave us gravity. Why is it negative 9.8 and not 32? Meters. Good. Acceleration is constant, meaning as you look through the problem, this is once again a free fall model, or this is once again a constant acceleration model. The acceleration is not changing. Not that we can't deal with that, just we don't have to. We just don't have to. Projectile launched vertically upward with an initial velocity. That's how I know it was launched, but the word's also there. It started with a velocity from ground level. As you guys are writing this, do you see why I'm going to write x sub naught is equal to 0 and v sub naught is equal to 33? I'm using x just because we used s the majority of the day yesterday, and I'm just reminding you it could be either one. You could technically even call it y of t because it's an up-down. If we're doing parametric motion, technically we call it y of t, but that's okay. Why did I say x sub naught is equal to 0? Who is x sub naught? X sub naught is just a snazzy way of saying x sub 0, aka initial. Ooh, who's this guy? Initial. Who? Position. Yeah, initial position is 0 because it's starting from the ground. Oh, you guys are killing me. Starting from the ground. Initial velocity 33, positive 33 because it's being pushed upward. Up. So it's traveling up. All right, when it says find the velocity, hold on, I don't have a velocity equation. Well, that's a bummer, except if I know acceleration is a constant, what can I always do to get to velocity? Integrate that acceleration. If this is all he is, okay, cool. dt. Wouldn't that be negative 9.8 t plus c? And who is that plus c? Because if I plug in v of 0 to be 33, that would be negative 9.8 times 0 plus c. Who is my c?
33.
My initial velocity. So I have negative 9.8 t. Which is why we said stuff like, hey, make this v sub naught, because he always will be that initial. Plug in t is 0, and then whoever's on the other side will be that c every time. Just showing that to you for a quick split second. But guys, what are they asking me to find? Velocity at?
3 and 5.
Velocity at. Now, if this was a long answer, what would you not have to do? Yeah, you would have to plug it in, but you wouldn't have to simplify. What do we have, plus 33? A negative 9.8 times 5 plus 33. Now, if you were to actually do this, and I think period 6 yesterday, we did the examples in a different order. So they were doing the paragraph today, and they did most of this one yesterday. If you were to actually multiply this out, let's see, it'd be 27 and 2.4, which would be 29.4, and then 33, which would be 3.6. A positive 3.6. 33 minus 29.4.
Yes, negotiated.
Yeah. A positive 3.6. What are the units of velocity? Oh, easy, because they gave them to me. Meters per second. How fast position is changing with respect to time. So every 1 second that passes, this thing, this object at 3 seems to be going up 3.6 more meters. However, as soon as you are past that 3, all of a sudden it's going to be even less and less and less and less and less, because what's going on if it was launched upwards to its velocities? They're decreasing because gravity is trying to pull it down, right? And eventually, I wonder if this is a negative. I have negative 45 and 4, which is 49, and then 49 and 3 is negative 16. Whoa, just 2 seconds later, now it's negative? Why is the velocity negative?
Gravity.
Somewhere in between 3 and 5 seconds, this thing, gravity overran the initial velocity and it started falling. Faster and faster. Okay. So somewhere between 3 and 5, I think, was that maximum. Oh, hey, maximum! That's nice. What's coming up in letter B?
How high will it be?
So somewhere, does this make sense? Like logically, somewhere between 3 and 5, it hit its max?
Yes.
And then it started falling after it was rising? How do we know for sure where it's going to hit the max? Or maybe a better question is when?
What's around 4?
What happens between velocity being positive and velocity being negative?
Change in sign.
There's going to be a change in sign, and what's going to happen in between the change in signs by IVT? A horizontal tangent, which means a what of velocity? A 0. There's a momentary resting point, right? Between being positive and being negative, there has to be a 0, so let's go find that 0. Let's find when, because I'm going to be finding t, when I hit 0. And when I hit 0, wouldn't that be at t equals 33 over 9.8?
Yeah.
Ooh, I'm done, right?
Yeah.
You always have to pay attention to what you're supposed to be finding. What does letter B actually ask for?
It's D. Would it be negative 9.8?
I subtract the 33 and divide by the negative.
Negotiate.
Question, am I done for letter B? Why not?
You have to get
How high? Adam is helping us saying the word position, but do you see that this is a where and it's not a when? I have a when. Perfect. But what do I need? I don't have position. I have velocity. Ooh, can't I steal that formula we wrote down yesterday because it's free fall? Yeah, but on the AP we don't really steal easy equations like that. We don't even memorize them. Because if there is going to be a motion problem, that acceleration is probably not going to be constant. It's something we'll have to actually integrate. So knowing how to move from one to the other is much more helpful than memorizing the basic free fall physics formulas. Could you use it? Yes. Is it better to integrate every time? As far as your memorization? Probably yes.
Most likely.
So if we were to go ahead and integrate, wouldn't we end up with, why am I going to put negative 4.9 t squared?
I don't know what all that jazz.
I know that 1/2 of 9.8 is 4.9, so I did negative 9.8 t squared over 2 plus 33t plus c.
But isn't C just B?
But yeah, wait a minute, hold on. If I plug in s of 0 to be starting from the ground, then that's going to be a 0, and that's going to be a 0. Isn't c just my initial position?
Yeah.
Oh, that's right. Oh, I'm so sorry. I called it s. I was trying to get you guys used to x. I forgot that.
You're confusing us. You
I
know.
know. There we go. So then c, or x sub naught, ends up just, oh yeah, it's 0. So the nice thing is, what is my position function? I almost did s again. X of t, just because it's the one I save and put online. X of t is equal to negative 4.9 t squared plus 33t plus 0. Haha, goes away. Wait, what am I supposed to be doing with this?
Finding.
How high? Good. Finding position when? Plug it in, plug it in.
Geez.
So couldn't I figure out how high it goes by plugging in the time at which I know that it momentarily stops? Negative 4.9 times 33 over 9.8. Hey, that's 1/2. Squared. Ew, gross. Not as easy as I thought. And then 33 times 33. What can we do with long answers? And we love it when we can.
Box it in.
Ah, label.
Label.
With meters. And then box it in, be done.
But I still don't know what's the answer.
Yeah, like practically speaking, how high does it go? I don't know. If you plug it into your calculator, you check with the back of the book, right? But for a long answer, we'd say we don't really care unless you ask us like an interpretation question. Letter C. Now what's it asking for?
Speed.
Ooh. Okay, so speed wasn't one of those fill in the blanks, but is speed necessary now?
Yeah.
Who is speed?
Absolute value of velocity.
Snazzy way of saying it, the magnitude of velocity, but mathematically the absolute value of velocity. Fine, the absolute value of velocity when when
hits the ground at x of sub-zero.
Do you guys see how a lot of these you have to kind of plug in something at one place and then use it at another place?
Yeah.
You're having to kind of like bring all of them together and work with different ones at the same time. Why am I saying that? Our goal is to plug in velocity at a time, but what is that time? I don't know until I come down here and say, Mr. Position, when do you hit the ground again?
0.
Right?
Yeah.
When are you back at 0? You start at the ground, but then you come back to the ground. When does that happen? Now, could some of you see this T and be like, hey, isn't that when it's at the max? And aren't parabolas symmetric? And if it started on the ground and it's returning to the ground, shouldn't the time just be double? That could be a really snazzy way of doing it.
I see.
But you don't always start at the ground and end at the ground. So just for sake of argument, because this might not always be perfect symmetry, because you might not always be like coming right back down. A safer way of doing this would be setting your position, which we already found in the last problem. Now, if this was a nasty quadratic, I hear Adam crunching numbers. That's because you're allowed to definitely use your calculator on this homework. You guys see decimals, right? How could you use a calculator to solve this? I mean, the factoring is easy. We're going to do that in a second. But how could you use a calculator to solve it?
Plug into it.
How about your y equals and you graph and you find the zeros? And you want to find the positive zeros. He should hit at 0, 0 because it started at the ground, but then go find the other 0. And isn't there a second trace in that menu 0 feature you can use?
Yes.
Very helpful to be able to find. But this one, I think we can technically just pull out a t, and we have negative 4.9 t plus 33. And remember, when you have factors equal to 0, I mean, we're just reviewing all of our math skills, right? We set each one equal to 0. Oh, we already know that. It starts at 0 when t is 0. What we care about is this one. Hey, was my hypothesis correct? It's going to end up being 33 over 4.9 seconds. Isn't that double what this one is? Nice. Parabolas are symmetric. Now, real life, wind and seagulls and other things might, kind of mess things up a little bit. But ideally,
You're not here to calculate seagulls or wind.
No seagulls or wind, huh? Party poopers. All right. Thank goodness. It'd be such a mess. Literally and figuratively. Okay, so depending on how big the projectile is, 33 over 4.9 seconds. We have to throw it into velocity and do the absolute value. Oh my goodness! Can a calculator do this for you?
Yes.
Yes. Could you put the velocity in the y equals and then do a nice little function notation? Yes. When we get to nasty FRQs and we're using our calculator, we will review all those skills. But long story short, I think someone, I don't know if you already plugged it in. Oh. It's negative 9.8 times this dude. Well, hold on, that's easy because 4.9 and 9.8, that's 1 and that's 2 and that's negative 66 and that's plus 33. Negative 33, which needs to be an absolute value. P.S. Joe Cal would be very proud because he said, wait a minute, It should just be the exact same thing as the initial velocity. That's how physics works yesterday, but we didn't get to actually finish solving, so today he will be very affirmed that he was correct. Anyway.
It'll always be like that?
Don't quote that. But ideally, that's how it should happen.
Okay.
If there is no extra force acting on it in the motion, it's just free. Okay, so, except Adam, remember how I said that something doesn't always start from the ground?
Yeah.
Especially if you're launching it, wouldn't it make more sense it's a little bit off the ground? And even if you're kicking a football, it would be on one of those little, or you're coming down, it's off the ground, it's not literally on the ground. To that end, that would change things a little bit because the initial velocity is not perfectly at the same symmetric point.
Mm-hmm.
Does that make sense? So that's why ideally yes, but practically you won't see that very often in the problems that are more practical.
You see it more like a rocket launch, where like it comes from the out of ground and it can actually sit on the ground.
Possibly, but even, well, rocket launches, but rocket launches from underground, it would have an initial velocity, well, and we have engines and boosters and all that
raises
stuff.
to like ground level.
I was thinking the thrusters though, it's usually on a stand.
But if it doesn't have to be on the
Yeah.
that'd be the only way you can launch something from
Right.
ground level.
Unless something was below the ground, like a punching or something, and it like made contact at ground level, yeah. But that's what you're thinking, like I just don't know practically whether that's ever the case, but yeah. Anyway, so we played with all that. There is, Adam, right, at least one, and maybe others that saw it, paragraphish one, meaning not like an A and a B and a C. Technically the A and B and C I think are usually easier because you kind of just break it down piece by piece. This one was weird. Remember, we had to pull out different clues and we had to plug in. There are ones that are similar but different, but I'm just bringing you back to the math real fast. This one was super awkward because it's like, I don't know this or this, that or that. I can't just solve and then put in a number. I have to solve for a variable expression and plug that in. Please don't freak out. It's called solving a system of equations by substitution. Once again, it's an Algebra 1, Algebra 2 skill. You just got to keep going, and maybe you are working with more than one equation at the same time. Use the one to plug into the other. And remember, if you are ever at the highest or the lowest, what is the velocity? If you're always at that, or if you are at the highest or the maximum or the lowest, the minimum, what will the velocity always be? Zero. Zero. All right, cool kids. Let's go back to our motion packet. I hope that's enough to kind of give you enough to keep working, keep attempting everything on that motion packet. We will go over questions, but once again, remember my challenge. This semester in Calc, I cannot allow you to do the whole, like, didn't make sense. Sorry. When you post, I cannot give full credit for that. I need to see that you are trying, you are persevering, you are digging in deep, you are reaching out and asking for help. Okay, you have to become more independent as students because in college nobody holds your hand and nobody gives you free points. There is no, I tried. Oh, okay. So I love you all, but that's not working this semester. So do the best you can. I'm not saying you have to ace every single problem. I'm not saying that you're going to totally understand everything. But you got to go back to our examples. You got to just try to plug in stuff. You got to reach out to classmates and say, can you just give me the next step and send them a picture of your work, okay? And remember, some of that could be off-campus tutoring hours. Okay. Example number 1. Working on this packet today and tomorrow, which is why in Google Classroom I said this isn't due until Tuesday because we have a day off on Monday. That's not me piling on work. Remember, I extended deadlines to give you more time, right? This isn't me piling on work. We're going to work on this packet today and tomorrow and bust out as much as we can so you have less to finish this weekend. Sound good?
Yeah.
Okay. We have info. And this is very, very, very AP-ish to be like, hey, guess what? You know some stuff. Here it is in a table.
Nice.
What do we know? We know that velocity can never not exist. Okay, that's cool. So velocity is continuous. Velocity is differentiable. That's kind of helpful to have in the back of our heads. Bless you. It always is. Velocity, position, acceleration. Continuous and differentiable. Other things, maybe not so much. But motion, yes. We know that we are measuring everything in meters per minute, so position is in meters, time is in minutes, and we know a few snapshots. We know a few snapshots of how fast at, 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 and how fast at. Question, could I graph each of these points and connect with a straight line? Because even though something might have been going -3, did it go straight to 2, or could there have been some variation? Come on, my drivers. Are you always on cruise control?
No, not in LA.
Not in LA.
All I know are snapshots, and there was 2 whole minutes? That's 120 seconds. Oh my goodness, so much could have changed. So whenever you have a table, you have to realize, unless it says something like strictly increasing or strictly decreasing, which this one, doesn't it seem to kind of go up and then down? But wait, couldn't there have been ups and downs to get here, and then ups and downs to get here, and then ups and downs to get here, and then ups and downs to get there, and then ups and downs to get... I don't know how many ups, downs. But I know at least it's not just going up. Okay. Just snapshots. At t equals 0. Okay, because I'm not exactly sure what was going on before or after. At, okay, I know that one. At t equals 0, is the particle moving to the right or to the left? Explain.
Left.
Good. Ryan, why left?
Because it's negative.
Good. The particle is moving left since v of 0 equals -3, which is less than 0. Dun 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 dun. Woo! That's not hard, is it?
Yes.
3 points. Maybe not free, but easy points. We'll take them.
That's a bad word, Misty.
What?
Free.
Wow.
Hey.
So easy, it's basically free. The particle is moving left since v of 0, because we don't have to work for it. Since v of 0 is equal to -3, which is less than 0, the particle must be moving to the left. Number 2, is there a time during the time interval 0 to 12? Remember, whenever velocity is negative, I'm moving to the left or down. And this one, well, it said along the x-axis. Isn't the x-axis right-left motion?
Yeah.
Got it. They love to put little particles on axes and have them like bouncing back and forth. Number 2, is there a time during, in between 0 and 12, when the particle is at rest?
Maybe.
Well,
No.
We don't work in maybes.
Yes.
it goes from
We work in definitely, at least. There is guaranteed at least.
Once.
Wait, guaranteed theorem. Those are IVT and EVT and NVT. There must be, there must be, there must be. I'm hearing yeses. I'm hearing maybes that hopefully turn into yeses. First
Yes.
of all, what's going on if it's at rest? It being the particle.
velocity is 0.
Velocity is 0. Hey, velocities! I got some, and I know that they're continuous, which means they're going to move through all the numbers to get from one to the other, maybe multiple times. Where do you see that there has to be a place where the velocity is at rest? Huh? In between?
0 and 2.
Time is 0 and 2. Good. So I can say the particle must be at rest at least once. You guys see where I'm going with this? Since v of 0 equals -3, which is less than 0, which is less than 2, which equals v of 2. And that resting point will occur. You guys are good to pack up. I'll show this on the screen tomorrow. I'm just finishing for the video. Will occur at some time t within, open interval, 0 to 2. Do I know where? Roughly. Do I know exactly when? No, but I know it happens at least once, because there's a sign change. Bye, guys. See you later. Bye. I-V.
Hey.
Woo! All right, bye, guys. Those theorems come back to concept. No, to be useful. To be useful. Good job, guys. Work on your homework. the motion packet tomorrow. Hopefully the motion packet feels easier than homework. Hopefully the motion packet ends up feeling easier. Because they were kind of behind with me being gone. They didn't watch the whole video.